Okay, so now we're going to build the same graph that we did last time, but we're going to add in some tools. One small change I am going to make, though, is this time for the state object, we're not going to use a pydantic object. We're going to use a typed dict. And it looks almost identical. It's just it's a subclass of typed dict instead of pydantic base model. But otherwise the same thing. Messages field, it's annotated, it's a list, and this is telling LangGraph that we're going to use the add messages reducer as a way of reducing. Otherwise, it's just the same. So you can stick with pydantic if you'd prefer, but this is a different way of doing it. So then we start the graph builder right there. And now we have something different. So it's worth keeping in mind, in your mind, that when we work with tools, there's actually two different places in our code that typically we have to worry about tools. And I've explained this up here. First of all, when we're making the call to the model, to OpenAI, that's the point at which we have to look at our tools and create all of that JSON nonsense, all of the stuff to describe what the tool is, so that when we prompt the model, it knows what it can do. So that's one piece of work that has to happen. And then another piece of work is when the model then responds, we have to test to see whether is the finish reason tool calls, and if so, then we have to do that stuff, which was the quite long-winded handle tool call method in the first week, where we unpacked the tool call and then we did some clever stuff. You can either have just an if statement, or you can have something clever that goes and finds the function and calls it. But that whole piece of the puzzle, the receiving the message to call a tool from the model, is like another place where you have to do all of your coding. Those are the 2 points, and we'll see both those points separately in how we have to handle this with LangGraph. So this is the first one. When we create the model, this is the chat OpenAI object, which is the LangChain wrapper around calling OpenAI. We also, once we've created it, we make another version of LLM, which is LLM with tools, which is after calling bind tools to the LLM. And this is just some nice sort of magic, which is going to then figure out what are the tools that it can call and make sure that whenever we call that model, whenever we call this version of the model, it's going to provide all of the tools it can do. So it's one of those examples. This is really powerful. It's LangChain here, and it's LangChain being really nice and making it simple to package away all of that JSON stuff and do it for us by abstracting around an LLM to have an LLM with tools, which whenever you call it, it's going to automatically pass in all the tools it can call. The flip side of that is that it's sort of hiding from us some of the implementation and some of what's going on, which can make it hard to debug and things. But you certainly, I mean, hopefully you see the positives very much. It's really easy. That is done. That now, whenever we call LLM with tools, it's going to automatically handle the building of that JSON and the passing it in. And so look how simple this is. This is our chatbot function. This is our node, our function for the chatbot, which just as before, we return messages. And then what we've got here is we just call invoke, but not on the LLM, but on the LLM with tools that knows already about those tools. It will build the JSON. It will pass the JSON in as the tools. So it's really clever. And then we add that node. And then there's this line here. This is part 2. This is the other thing. This is handling the results back. So what's happening here is that we added that chatbot node. We're adding a second node called tools. And it is a special type of node. It's a tool node. And when you create a tool node, you have to tell it, okay, what are these tools? What is it that you do? And this tool node is basically like a canned node that when it's invoked, it's going to see whether any of the message is asking to call one of the tools that it's been assigned, that it was passed to it when it was created. That's the job of the tool node. And if so, it will run them. So one more time, this piece of code here is handling the request to the LLM and packaging up the tools JSON. And this node here is handling what happens if there is a tool request. It's handling the unbundling of the request and the actual calling of the tool function. And if any of that didn't make sense, I think it hopefully will do very shortly. we're going to create the edges now. And again, a little bit more complicated than before. So there is an edge which is going from the chatbot to the tools, from this node, which is the actual chatbot, the LLM with tools, to the thing that calls tools, to the node that actually runs the different tools. We need to connect those two. But that connection, it's a connection which has like an if attached to it. We don't want to always call tools. We only want to call those tools if the model has returned a response that the finish reason is tool calls. We had to like code that ourselves in week 1, if finish reason is tool calls. So that if has to be included in here, because it's only if that's true, it's only if the model returns that it wants to call tools that we actually want to call this node. And so that is why when you look at this edge, it's not a normal edge, it's called a conditional edge, which means it's an edge that's only triggered in certain conditions, and like an if statement. And you give it the node name, you give it the condition, and you give it the node that would then be called. And that condition, called tools condition, is again pre-canned with LangGraph. And of course, it looks to see if the finish reason is handle tools. The finish reason is tool calls. And so that's exactly what that does. So when I used to say that at the end of the day, tool calling is just an if statement, this is the if statement. This thing here is handling that if statement. And if this if statement is true, then it's calling a node called tools. All right, and then there's one more quite subtle point here, which is that you also have to make an edge between tools back to chatbot again, because the result of this, the result of running the tool, the output, needs to get fed back into the chatbot, and it needs to continue processing from there. So this is subtle, and once I've said it, it's probably obvious, but it's one of those things that if I hadn't said it, it's not something that would naturally have occurred to you. And if you don't do it, then things will go wrong in strange ways. So it's one of those times, again, it's elegant, it's neat, it's great that LangGraph does that, but it can make it a bit harder to debug. All right, and then we're going to add that start edge. And then we're going to compile and picture it, and this will hopefully bring this together for you. Start goes to chatbot. This is a conditional line. If the finish reason is a tool call, then it will come here because the tool's condition will be true. Then it will be responsible. This node is a canned node that's responsible for calling the tools that are relevant. And then the results comes back. And this is a solid line because if it's got here, it should always come back. And this is a dotted line because only in the event that this didn't happen, then it will come to end naturally. LangGraph automatically adds an end node for any unresolved condition like that. And so that is our graph. And I hope that seeing that graph has made it come together for you. So the two places where tools are incorporated, one is the chatbot itself. We're using the LLM with tools, and the other is in the conditional branch and this tools node itself. Well, I think it's enough chit chat. We should get on and run this thing. So here we go. We're going to, I think I'll make this consistent with how we've done it before. We'll call this chat, not invoke graph, but it is how we should think of it really. So we're going to bring up a Gradio screen, and we're just going to call it. Let's see if this works. Okay, so I'm going to say hi there. Hello, how can I assist you today? Well, I'm going to do something fun here. I'm going to say, please send me a push notification with the current US dollar to Great British Pound exchange rate. So I'm hoping that it's going to look up the exchange rate by doing a web search, find it out, and then send me a push notification. This is ambitious. Two tool calls in one shot. Get that out of me, and we'll see how it does. So it's going, it's off, it's pausing. It's as you heard, it certainly sent me something. The current USD GBP exchange rate is 0.78. Well, I happen to have a Google screen sitting over here. Let's bring this into view. There you will find the current US dollar GBP exchange rate is indeed 0.78. So that's cool. That's cool. I hope you agree. Sorry, get that out of your way. I hope you agree. It's interesting to see that this has happened and that it's achieved this. And what we can see here is that we can come into Langsmith and see the outcome of this. I'm interested that it's put that in red, the 4 seconds that it took. So let's go into this and see more. Please send me a push notification with the current USD GBP exchange rate. So we can see that you can see the whole graph playing out here, and it's fascinating to see. Let's scroll down. It's doing a search right here. Click here. Current USD to GBP exchange rate, and that's the result that came back. This was from doing the search just as we expected, and then it came back to a tools condition, to a send push notification, and back came the answer, and then that was the conclusion. There we go, and that's how it responded. So there we see the full chain of discussion happening within Langsmith, and how you can come in and debug this and see what's going on, and see, indeed, convince yourself that it did call the couple of tools. And this was great fun, and I hope you'll do the same thing. Come in now and run this, let it call both tools, go into Langsmith and trace through to make sure that you can also see all of these calls happening just as we did right here. And I've come into Langsmith one more time just to show you. I think I read from the wrong place there. The final output from GPT was right down here. I have sent you a push notification with the current USD to GBP exchange rate. So that's where you saw the end of the whole of the trace right down at the bottom there. Okay, so here we are back in this chat. And now let me just show you something. Despite its incredible intelligence with this conversation, what we can now say is, my name's Ed. Nice to meet you, Ed. How can I assist you today? And I can say, what's my name? And it says, I don't have access to your personal information. So I use this as a way of showing you that despite the fact that we have all of this state management, despite the fact that we've built up these reducers and this clever structure, it doesn't have any memory. It doesn't have the ability to remember between the different conversations. And you might be thinking, well, I guess you're not thinking because I explained it already, but if I hadn't explained it, you might be thinking, but hang on, why we've got all these reducers, we've got all of this stuff to handle state and to add in state. That why isn't it just naturally remembering what's happening? And yes, it's all down to super steps. The point is that every invocation, every time we call this graph, it's like a separate, fresh invocation. And state is managed and maintained within any one invocation. That's what it's there for. It's to handle so that you could have multiple nodes running in parallel. You could have all sorts of stuff happening, and the state will be managed through the whole graph in a reproducible way. That's the power of the state management part. But that doesn't help you between separate supersteps. Each superstep is a different invocation of the graph. And the way that you do this is you use checkpointing. That's how you add memory. Well, I have to tell you, I have some misgivings about LangGraph from time to time, how heavyweight it can be on occasion with some of the things we have to learn. But this is one case where I am very impressed indeed. And it's a moment for me when I get it. I realize why people like this so much, and I can really appreciate the power of it. Checkpointing is very elegant, very simple, and it leads to robust, repeatable processes. And you will see that too, and I imagine you'll be impressed like me at the end of it. So we begin by creating a new object called memory saver. And a memory saver doesn't mean like saving memories. It's talking about saving to in-memory stores, to in-memory rather than to disk or to a database. That's a bit confusing. So that's what memory saver means. Then this is the same code we had before, exactly the same code. I put in a print statement so we can see what it's doing. And otherwise, the only change is when we compile the graph, we pass in checkpointer equals memory. We're passing in that memory object. But there's our graph. It looks identical, exactly the same. And now this is where we actually run the code. There's a little bit of stuff here, which is a bit hacky, a bit hokey, but the idea is you have to create this object called config, It's a dictionary with one field, configurable, and in that field you have to put in a thread ID. And thread ID doesn't mean like a technical thread. It's meant to be like a conversation thread, like it's something that refers to this thread of memories that needs to be connected together. And so that's how you specify that this is this particular grouping in memory. And then when you invoke the graph, you have to pass in that config. That's how you make sure that when you're invoking the graph, it's being associated with the right sort of slot in memory. And that is all there is to it. So with that, let's bring this up and we say hi there. Hello, how can I assist you today? My name's Ed. Nice to meet you, Ed. How can I help you? What's my name? Think it's going to get it? Your name is Ed. How can I help you further? And no surprise, you can see down here the print statement that I mentioned is printing out the inputs, and we're getting the full history each time. And that is all there is to it. That is checkpointing in action, maintaining memory between each of the calls, each of the super steps. Now, I know what you're thinking. You're thinking, oh, Ed, what's the big deal? Why are you so impressed by this? I mean, it's just like you could also get there just by storing that list of dicts, or we could take it from Gradio's UI here and put it in a global and keep playing it in. Well, look at some of this stuff. So you can call graph, the compile graph, .get state, given the config, and we get back this thing called a state snapshot. And this has in it the messages and then the complete the conversation so far. Yeah, all right. So it's like a global that has this in it. But there's more. You can get state history for our config. And what we get now is each step in time, every super step, every time we invoke the graph, the complete snapshot at that moment, starting from most recent at the top and then going back in time. And this is where it gets cool. And it's not like it's super sophisticated, but it's definitely a cool construct. LangChain allows you to step back in time to any prior moment. When you're passing in that config, the configurable with thread ID, you can pass in a checkpoint ID to kind of rewind to a previous moment and then replay that through the graph. And this gives you this ability to basically do what they call time travel. That's the LangGraph official name for it, which is really to be able to move back, get your snapshot at any point in time, and be able to rerun it from there. And this is really great because it allows you to build systems that are repeatable and robust. If something falls over, you can restart it from any snapshot, any point in time, and you've got this kind of full tracking on everything that happened. So yeah, it's simple, but it's elegant. And this is a case of an abstraction that really makes sense to me, and is definitely something that I think is very valuable. And I just want to show you as well that this has got nothing to do with Gradio and with kind of variables. I can come back in and I can just relaunch my Gradio UI right here. And I can say like, hi there. It says, hi again, Ed. I was going to say, what's my name? But I don't need to. You can see right away. It's got the memory. It's still got that memory. It's got nothing to do with the information stored in Gradio's chat UI, which is what we've always used in the past with Gradio. But rather, it is the memory, the checkpointing that's happening inside this memory object. And then I can come back, and if I recreate, I can create a fresh new memory saver object and come in, and then I have to rebuild my graph with the new memory right there, and then bring up my chat interface. And now if I say, hi there, and what's my name? It's obviously not going to know it. So that just explains that by recreating a new memory object, we've reset everything. And that gives you a good sense of what's going on. My name's Ed. Nice to meet you, Ed. How can I assist you today? What's my name? Just to prove the point, your name is Ed. And then let me just show one more thing here. We can also change the thread ID to 2. Let's rerun this and take a look here and say hi there. Hello, how can I assist you? What's my name? And it says it doesn't know because the thread is 2. If we now go back to the thread is 1, I know you get this, but it's worth saying. And now, hi there. Hello again, Ed. So there you see it. It's a nice, elegant, it's relatively lightweight and simple, but very powerful. And that's a nice combination that I can get behind. And you can come in and look, of course, at the different checkpoints for either thread number 1 or thread number 2 using the same this same structure. And now for my next trick, and our last trick for today. I'm going to switch it to store it in SQL instead. Our memory is going to be in a SQL database. And again, this is impressive stuff. It's great that it's so simple and easy to switch to using SQL. We just import this SQLite saver instead. And we're going to write to a memory.db. We connect that way. We come in and it's just exactly the same code, but we're of course putting in the SQL memory instead of the memory before. I mean, it's just a different name of a variable, but it's exactly the same approach as we had before. Nothing different there at all. There we go. I'm going to make the thread ID a different ID because since it's SQL, it's kind of remember from my tests. But then we can come in and we can say, hi there. And see, how can I assist you today? What's my name? And I don't have access. My name's Ed. Nice to meet you, Ed. How can I assist you today? All right. So with that, we can now go back here. And this time we can just recreate the whole thing from scratch. It's like I could restart my kernel. I should restart my kernel. Why don't I do that? You'll have to bear with me. We will restart kernel, clear all outputs. We'll go all the way back up to the top, run our imports. We will load the .env. Just check, I guess I should load in the tools again because we're going to use these, do this, get the pushover, message me. My phone's on silent. Bring them together, get our state object because we reuse that at various points. And now from this point onwards, I think now we can now go back here. So we're completely fresh. So now we're going to recreate this. We are going to rebuild our graph builder. There it is. And here we go. And hi there. Hello again, Ed. There you have it. Restart the kernel, completely bring everything fresh. And of course, it knows who I am. And it knows that because you can see right here in this directory, there's a bunch of database objects. It's storing it in a SQLite database. And so we have persistent memory with changing like one word from our code. And I think that is really impressive. And I realized just before we close this, I should also show that the tools are working and in action. So after saying this, I should let's do the same thing. Please send me a push notification with the current USD GBP exchange rate. Let's let it do its thing. Off it goes, and I just got a push notification, and it says 0.78. There we go. So success. I think maybe just let's what if I say like I'm trying to think about how we can use memory as well. Can you send that? Can you send that push notification again, please? Let's try that. There we go. I got another push notification with the same thing. So there, I had to think for a moment, but there's a demonstration of both memory and tool calling in one shot with the right answer. Success. And you can see the various calls happening down there. So that then is a wrap on this. And it might be nice for us just to bring that up in Langsmith just to see those calls. And so here we are in Langsmith looking at that most recent request, and it's good to see that, as I was hoping to see, it did use the tool to send the push notification. It didn't bother doing the search again because it had that in its memory, and you can see at the bottom here that it sends that push notification, and it then confirms back there that it did it, just as we saw in the chat, and you can see all of the history that it's got up above it. So you can see in Langsmith that true to its word, everything is working, the memory is working, the tool call is working, and it knew that it already knew the exchange rate. So I'd say that that is a success. And to wrap up, let me show you one more time this great picture, which now I hope lands nicely with you. We define our graph, we run each super step with each interaction, and these red lines are showing the checkpointing that's happening so that we can resume at any point, we can replay the state as it was then, we can time travel back, and we can persist this in a database so that it maintains knowledge of the conversation and it's keyed off this thread ID. And with that, that concludes day 3, and it was a meaty day. We covered a lot of ground, and I hope that you're building some of the same enthusiasms that I'm growing as we get into this for LangGraph, and seeing the strengths, seeing how resilient, how robust it is, and this discipline that it puts around the process. But that's enough of the learning and the concepts. Next time we launch into our project called Sidekick, and it's a really great one. I can't wait to show it to you. See you then.